And welcome back. Before we start, a gentle reminder to please do remember to either switch off your cell phones or put them on silent mode. We are ready to start with the post-T session, which is Secure SATCOM and Integration with IoBT, IoMT systems. This session is being chaired by Major General Sanjiv Sharma, SM, ADG, Taxi, DG Signals. The esteemed chair and moderator for this session is already here in our midst. So the esteemed speakers for this session are as follows. Dr. Ranjana N., Director DSTA DRDO, Mr. Sanjeev K. Gupta, Associate Director SATCOM Applications, SATCOM-PO ISRO Headquarters, Mr. Vinod Kaul, RVP South and Southeast Asia, Gilat Satellite Networks, Mr. Krishna, CEO Pinaca Labs, Mr. Dilip Singh, CTO QuNu Labs. May I request them all to please join us on stage. Let's welcome them with a round of applause, please. With that, I now hand it over to the esteemed session chair. It's over to you, sir.
Good morning, everyone. Senior defense officers, colleagues from industry, and the esteemed panelists. At the outset, I take this opportunity to thank Team St. George and SIA for conceptualizing and organizing this very interesting and I would say innovative session on DefSat. I firmly believe this kind of focused approach and the interactions between industry, academia, defense would eventually lead to long-term development of our nation's capability and very much in line with the Atmanirbhar Bharat. Today morning, one of my colleagues sent me an interesting article, the gist of which was, the world is in IoT space race. So I'm glad to be here today to discuss something which is becoming increasingly important, that is secure satellite communications and integration of same with the IoMTs. The world is increasingly becoming more and more connected, and so are our militaries. And I recall having read long time back a book by Alvin Toffler, we would have all read about it, The Third Wave, where the first wave was the agricultural wave, and then we moved on to industrial, and third wave being the information wave. What I perceive, and today we have already passed actually fourth wave, which could be actually interconnectivity or the networks, and into the fifth wave, which is our ability to address individual devices, what we call as IoTs. And it is this increased connectivity and ability to address the individual devices that is now bringing an explosion of IoTs across the world. Each key word in today's session, secure satellite communication and integration with IoTs, has its own nuance. If we talk about satellite communications, I understand over the last 2 days enough discussions that happened where we categorized the space application into ISR, PNT, and communications, where communications actually become an overarching element and subsumes both the PNT and ISR. And therefore, the communications have to be secure. So what I want to say that communication is like the prana to the body or their breath to the satellite. A space asset which loses communication will be declared lost. Examples are our own GSAT 6 Alpha, and very recent example of Japan's Hakuto R lander, actually, which lost contact. It was supposed to be landing on moon few days back. And the next thing is the connectivity now, after the communications. And with IoTs become key drivers of growth in many areas. So there will be requirement of connectivity of these devices all across. And as the need of connectivity grows, the terrestrial networks cannot keep pace. You will be going in far-flung areas where the networks are not available. So therefore, the satellites come into play. And as this kind of connectivity is increasing, therefore, there is the increased threat, either of cyber attacks, data breaches. A lot of threats were talked about in the morning session today. So these kind of threats come into play, and this is where there is a requirement to secure these. In addition, there are additional challenges when you look at IoT satellite connectivity. First of all, the IoT architecture today itself is not frozen. So we have challenges of low power requirement, very small form factor, because IoT will generally come in a small form factor. While there are protocols which are available like LoRaWAN, which has come recently by the Lacuna Space, and narrowband IoT. But the challenges remain. Then you have kind of lightweight yet robust IoT devices needed, and the security protocol for this. And lastly, coming on to you do not have actually a standardized framework for the security stack as well as for the firmware. If we specifically look at the military requirements, now this kind of what now in military terms what we call as IoMT, this has its own typical challenges. Many of the ISR devices which we use, they are not classically what we look at IoT in the civil parlance. They are the sensors which are legacy equipment. They have all kind of diverse outputs coming out of them. So there is therefore requirement which will be coming where actually we need to integrate this legacy equipment and the diverse equipment, keeping the requirements of security in mind. And we look at this also, there will be an additional challenge coming up. If you have large number of IoMTs in a battlefield or in a place where now you're the forward areas where the troops are there, then there is a danger of giving out your own intentions, because they'll create signature, and this signatures will get picked up from the various surveillance agencies. Apart from this, now since the data is very diverse in the military domain, there will be an additional challenge coming up to how to get this data which were gathered from the diverse devices coming in completely different formats to create something coherent which is more readable and finally more actionable. So in today's panel discussion, we'll set tone for this, focus on challenges and solutions that we face in securing the satellite communication and connecting the IoMTs to that, especially in the field, in defense. We talked about the risks today. We are aware there's a risk which can come in form of interference, can be spoofing, cyber attacks, data privacy, and so on. But then you have solutions coming in place in the form of encryption. We talked about QKD in the morning, PQCs in the morning, authentication, frequency hopping, and then you have things coming like beam steering, network segmentation, and so on. Dr. Anupam in the morning spoke about antenna nulling, and he also talked about the quantum techniques coming into for the protection of this. So I'll not stand between you and the very esteemed speakers to unravel all these challenges and the mysteries. We have before us a very esteemed and highly qualified panel of speakers. Each one of them is a specialist in their own domain. What I do is I'll just introduce you briefly, and then we'll run through each. I'll request each speakers to take about 10 minutes per session, and post that will be open for the question answer session. We have with us Dr. Ranjana, who is director at DSTA, DRDO. You heard in the morning, a very eloquent speaker. She spent more than 3 decades in various domains, and she is a doctorate in computer science, a quality practitioner and architect. She is morning articulated and gave a lot of insight into industry, academia, and DRDO, how the user can interface to the TDF funding. And we'll be hearing more from her. And then we have Mr. Sanjiv Gupta, who is Associate Director, SATCOM Application in the ISRO. He's been working making immense contribution in design and development of TTC systems and remote sensing and interplanetary mission. He also works for implementation of Earth stations of high throughput satellites and utilization of the same for various services. He is a proud recipient of Team Excellence Award of ISRO for the RF systems for the Mars Orbiter mission. We have Mr. Vinod Kaul, who is a regional vice president South and Southeast Asia from Gilat Satellite Networks. Vinod has about 28 years plus experience in IT and telecom. For the last 20 years, he's been working in telecom industry in various roles, and he's been actively working the Asia's markets across Asia and developing South satellite expansion connectivity in the markets in Asia. He holds bachelor's degree in electronics and communication from National Institute of Technology, Surat. We have Mr. Krishna. He is CEO of Pinaca Labs. He's also founder of a cybersecurity startup called Saptang. I was asking him actually meaning in the morning what is Saptang means. So he says to interact with the 7 verticals of the government to create cybersecurity solutions. That is a very interesting name and the intent also of the company. And he has been earlier Indian Revenue Service Officer of 2011 batch, and also served in the National Critical Information Infrastructure Protection Center in various capacities. Last, on my team left, he's Mr. Dilip Singh. He's CTO of the QuNu Labs. QuNu has been working as a company on quantum domain basically mainly, and he's been working on QKD products like QKD P2P systems, QKD hub and spoke, and QKD trusted systems. And Dilip holds a bachelor's degree in electronics and communication from IIT Roorkee. So we'll start with Mr. Vinod for the session, and I'll request him to come on the dais.
Good morning, everyone. Thank you, General Sharma, for the introduction. Good morning, esteemed officers, my co-panelists, industry colleagues, and the august audience. Thank you, SIA, for a wonderful DevSat. I mean, it has been a successful 2 days of interaction between industry and the officers. So I will run you through something from on the SATCOM and IoT. General Sharma gave starting points on what we're going to discuss. So I'll run you through more on the topic. To the next. So I go next from here. Okay. So just a brief, I'm from a company called Gilat Satellite Networks. We basically manufacture ground equipment technology, which is to baseband, NMS, modems, antennas, bucks, and we also have very specialized on-the-move antennas, man-pack terminals, and we address not only the defense market, we address commercial enterprise markets also, and we're very strong in the telecom vertical, where we offer our solutions to telecom companies. So we are around 1,000 employees. We're based out of Tel Aviv in Israel, headquartered there, but we have offices in 15 countries worldwide. We've got R&D centers across the globe. Just to give you, we work with varied customers, which is satellite operators. We work with service providers globally, and we have networks in 100 plus countries and hundreds of networks. In India specifically, we've been here from 1999. We have multiple hubs. We have 120,000 plus terminals working in the country. We have an in-house in India repair center. We work with many partners in India, which is telcos like Reliance, Bharti, Hughes, and many defense PSUs and other public sector units. And we work with system integrators globally for US Department of Defense, where we work with L3, Honeywell, General Dynamics, to name a few. Industry as a satellite, if you see, is going through a major shift in the last 2-3 years. You have the design of the satellites have changed. You have software-defined satellites, which is a new trend. You have production of satellites. The demand is a lot. So the production has changed. The delivery times have reduced for manufacturing any kind of satellite which you seek. The launch facilities have changed. There are payload size, the way the satellites are getting launched are changing a lot. The orbits have got redefined. You have you generally used to work with GEO was the predominant orbit. We have now GEO, MEO, and LEO, where the more action is happening. The operation of the networks has changed. You have different basebands requirements, how to talk to the satellites, because they're moving, they're high throughput. So a lot of changes in the satellites, and then the services. You have now in-flight connectivity available nowadays, which was not there a few years back. Which the satellite technology has enabled, that you can have internet access while you're on the flights. So if I talk about the constellations, we just to give you a very brief very overview of constellations. You have the GEO constellation, which is very predominantly ISRO is working in this constellation. You have MEO and LEO, which is where the action is happening. To name a few, on the MEO side, there is ACS O3B, which we are working with Reliance in India. They have formed a new JV called Reliance ACS, where we are partners for the technology front. There is Telesat, OneWeb, SpaceX, Amazon, which is going to come very soon. They are on the LEO side, where terabytes of capacities are being offered. You have a new concept called high altitude platform systems, HAPS, which is where you have a balloon or a ship kind of a stuff up hanging in the air, providing connectivity focused on a particular area. Just a number, more than 50,000 LEO satellites are expected to be launched in a decade, and the huge investments happening in this direction. And generally, to talk about GEO, which is very predominantly still where ISRO is working in India, we have a move from Gbps to terabytes also on the GEO side, and there are a lot of ground technologies which are getting developed to address and connect to these new satellites. When I talk of software-defined satellites, this is what something is working on. You can always nowadays define the capacity over a region, or you want to change the capacity from one region to other region. You can control from the satellite to address a particular region, and if the traffic is more in this side or that side or wherever the need is, you can really maneuver the satellite to provide connectivity to that area. And obviously, when you talk of such satellites which are moving, which are in orbit moving, and also have a software definition of how to allocate capacities of on the ground, you need ground segment technologies to address that. So you need to have elastic NMS and a different kind of data centers and basebands to cater to that technologies. Gilat is one of the pioneers, and we have a technology under the name SkyEdge, which addresses such kind of requirements. That's the baseband side of it, where we can offer specifically, we're talking here defense, maritime, and IoT applications can be addressed by using such kind of baseband technologies. Now, if you come to the topic, this was just an overview where the satellite industry is moving. If I talk of Internet of Things, we're giving it name battlefield and military things. The same IoT, which is in the commercial market, which has been on from the last few years. Now we're basically addressing it to a battlefield or a military environment. Basically, just to give you a very basic idea, what we are talking about is that you have a network of sensors which are wearable IoT devices, and then all of them is they deployed, for example, in a battlefield, and the battlefield assets, which are soldiers and military equipment, is air, marine, land, wherever you want to deploy the sensors, they're all connected through a secure 5G or a Wi-Fi or a Bluetooth or an NFC or a low power WAN kind of an environment. And all of that data which is getting created is then either directly connected via satellite, which is, we'll talk a little bit more about that, or you use edge computing, and there's a security aspect to it, and you use edge computing, and then you backhaul the whole data over a satellite link to the command headquarters, and where the analysis is done. Now, the SATCOM, is the link. You can deploy in today's networks hundreds of such islands of terminals, and have the data collected from all of them in simultaneously. The technology enables to do that. And a couple of points which I would like to focus on here is there are two methodologies of how do you address the IoT, IoBT or IoMT market. One is satellite as a gateway. That's what we are doing today, and which is happening today, where you basically, the last mile is connected on a private 5G secure network or a Wi-Fi, and then you backhaul this whole thing over a satellite to a central command, and then you analyze the data, you analyze it, and then send it back to the front area, where to the theater, if it is a theater, or if it's a peacetime area also, and with the analysis. Other way is that, which is the new where the new action is happening, is that you have direct to satellite sensors, where you are directly connecting a sensor to a satellite, and then getting all the data to a central headquarter, where you have kind of a AI or a platform which analyzes the data, and then gives it back to the front commander who is in the front to understand what to do with it. The integrating of the signals and this data is a very challenging aspect of IoT when you talk direct to a satellite, because when you talk direct to a satellite, couple of things are happen. One is that the satellite, the sensor has to communicate to a satellite, so it means it has to have some kind of capability, so which increases the cost of the sensor. The power consumption becomes a challenge, and then it connecting to a geo becomes bigger challenge. So that's why you have LEO satellites, with CubeSat kind of technology, which is now getting predominant. So you have LEO satellites which can address to such kind of small sensors where the data is in bits and bytes, and then you access that connected sensors to it. So we still have a lot of challenges in the devices of that nature, where the low cost, low power consumption, cost effectiveness becomes still a big challenge. So when you look at smart warfare, the SATCOM does bring some value on the table for the defense forces. You can connect all your battlefield assets via a satellite, using IoT for whatever kind of information you are seeking. And then satellite is, you have a modular and scalable architecture. The performance, you can change the bandwidth, whatever you want. You want small, you want high, you want, whatever kind of bandwidth you're seeking, you can use it. And then end of the day, satellite does provide you a secure and security aspect, which I'll talk a little bit later. And that's how we see the advantages of SATCOM in such an environment. And then, the kind of, when you look at satellite as a gateway, what kind of terminals you can deploy on the edge computing sites or on the front things. So you have COM on the pause terminals, COM on the move terminals, and where we offer full solutions for such kind of gateways, basically the SATCOM links. Wherever you want the fully VSAT integrated antenna solutions can be deployed for connection to the headquarters. and they are all rapid and quick deployment. In case of whenever there is an emergency or whenever there's a challenge, fully automated solutions are available. So to say that whether you are in all theaters, land, air, water, the SATCOM solutions are available to backhaul all the IoBT, IoMT devices, and whether it is a UAV, which is a new market where we have connected UAVs where you want to backhaul, you want to connect them on a SATCOM link, or whether it's a armored vehicle, or it's a tank, or on a ship. Coming to the security aspect of SATCOM networks, it's the most important thing. The satellite cyber attacks are common in telecom networks, and because of the open air communication nature of satellite, they are more sensitive to attacks. And so cyber security is a must in SATCOM. So if you look at the basic cyber security networks, so you have encryption on VSAT links, you have Transec. You can have segregation of the planes. The data control and the management can be on a different plane. You use the latest firmware and the software. When you go more advanced security SATCOM solutions, we have zero trust security model, which many of you will be aware of. Encrypt everything, anomaly detection, and then you have these vulnerability tests. Manage a risk register and perform vulnerability assessments and run penetration tests. So this is a very overview of the cybersecurity, what we do address. Coming to the summary, Sharma is watching at me.
Yes.
We are on the time. So IoT has strong military applications. You can basically it helps to create a cohesive network, to increase situational awareness, risk assessment, and response time for the forces. And satellite industry is responding to the IoBT connectivity demands, and we have solutions both satellite as a gateway and direct to satellite options, which can be explored. And end of the day, you have SATCOM gives you a secure, scalable, anytime, anywhere network for an IoBT. That's from me, sir. Thank you. Thank you very much.
Thank you, Mr. Kaul. You very actually eloquently put across the nuances of IoMT connectivity for increasing the situational awareness, and also the ways of integrating the signals from diverse and dynamic set of sensors, the backhauling, use of AI capacities, and the elastic NMS, which is an interesting concept, and also elaborating the cybersecurity requirements. We'll invite the next speaker, Mr. Sai Krishna, and I'll also request all the speakers to actually stick to the time of 10 minutes and moderate your talk accordingly.
Thanks, Chair. Thanks for the opportunity. Good morning, everyone. So I'll quickly try to cover the important topics that we're looking at. So basically, like I think many of the other speakers have already highlighted, cyber and space are live in a continuum. They are very interlinked. And cyber is one domain which permeates through all the domains that we have. So truly it's called the fifth domain. I'll try to restrict my comments more largely on the cyberspace and cybersecurity issues. So I'm sure I'll try not to comment on the RF and other angles. I'll try to fix to only this. So now this is how broadly the attack surface from the cyber point of view looks like. So there are hundreds of IoBT devices or the IoMT devices probably operating in the battlefield. So they may be switching over constantly between the local telecommunication that is provided by 5G type solution or also by SATCOM as a backhaul or a backend. So this is the situation that we are looking at from the attack surface point of view. So with this in mind, let's look at what type of challenges we would face. The challenges we'll face largely come from the bugs or cyber bugs that are found in the communication equipment itself. Second part, in the sensors themselves. And of course, the software that lies on the platform which deals with the sensors. And the firmware that enables these sensors and applications to interact with each other. So these are the major areas where a cyber attacker would be interested in probing, and which is exactly where we should be interested in. stopping. Same structure happens with the satellite. I'll not cover it because satellite has a much better environment to deal with because there are very few satellite manufacturers. There are very few standardization things that are set. So you have labs under your control. So you will be in a position to verify the standards if you set one. And also industry is also relatively smaller but much better organized. So the challenge becomes manifold when you deal with the IoT industry because there are not many standards in place. Even if you try to set standards covering the aspects of sensors and software that deals with the sensors and the firmware, it will be difficult for the services to even enforce them because there are many manufacturers. So now I'll try to cover the presentation in 3 slides: design, and also deployment and after deployment. In design stage, I think the first solution that we can presume is that the communication is broken. How does the IoBT system behave with itself? They're all within range of each other. So probably a solution that we would be wanting is a host-based intrusion detection system, which is enabled by AI. Now in this situation, the primary capabilities will be to identify, am I connected? Do I get any guidance? What was my last guidance? Based on my last guidance, am I safe? In the sense, is enemy controlling me, or am I operating with my owner? So this type of detection is needed. So you can build this by using artificial intelligence models. So models will know the unauthorized access or firmware updates and those type of things. And just in case the model determines that I'm being controlled by the enemy, or my orders are not coming from the authorized channel, so system should be in a position to activate a kill switch and disable itself. Because putting a weapon which enemy can control is a very dangerous idea. Now coming to this, this is the 2 situations that we are trying to handle in the design stage itself. Now the third thing that we need to do is, let's say there is an EMP blast or something. So we can have a secure cage which kicks up so that the rest of them are fried, but this baby is still on. But that baby cannot interact with anyone. So there can be a safe programs that are kept inside on what to do as a standby or something. So this again requires use of artificial intelligence and some sort of a advanced sensor. Now in these 3 slides on the top, we kept on talking about artificial intelligence. And the 4th slide is to set standards on ensuring that AI doesn't misbehave. Because most of the AI devices that we use and models that we use are black box. So we need to set some standards to ensure that the models don't misbehave or don't behave erratically or don't go rogue. So obviously no one wants a Skynet here. Yeah. So setting these standards is another thing that I think will help the industry also to grow forward. Yeah, I'm sorry. Ready? Yeah. Now before deployment, let's say the design is done. Before deployment, most of the sensitive agencies use equipment which is either imported or manufactured by multiple people across the supply chain. So the one basic step that you can do is to do firmware binary analysis, which is basically like a black box testing. This will at least prima facie give you a confidence that you don't have any backdoors in the system. And second part is, I think you can also insist that you should be permitted to do fuzzing, which basically means to create scenarios where the firmware that is used in sensitive equipment is tested by a third party. So because the hacker is exactly going to do the same thing. So why don't we find bugs in the software that we are using before someone else finds? So this is a slightly complicated and very capital intensive and also effort intensive and expertise intensive thing. And while we are doing this, we can also simulate a deliberate malfunctioning of sensors. Because like we discussed in the earlier slide, sensors are also a very important attack surface. So we can simulate that and see how both the firmware behaves and also the application, how would they behave. So these steps will at least give you confidence that yes, the tool that we are going to deploy or the machine that we're going to deploy, maybe in the space or maybe in the battlefield, doesn't behave rogue. And second thing, of course, once you deploy, it's essential that you have your own monitoring system for all your devices. Again, here we are presuming that you have communications, connectivity back to your central command, from where you are monitoring the battlefield. And another very, very important point is, see, if you are a hacker, if you think from the hacker's point of view, the best attack will not come from attack on the services. It always comes from attacks on the vendors, because they are the easy link. So services also should take extra interest in ensuring that the industry and the vendors are also not attacked. Now, how do we do this? I'm sure the services can have a view on this. So I'll try to quickly put another couple of points. Now, if you look at the legal framework in India, we have a concept of national critical information infrastructure. So the Act excludes defense. So the defense suppliers and the defense units have to decide on their own on how do they deal with what is known as critical information infrastructure. Now, some guidance on this will definitely help the industry, because the industry also can take up with their own boards and others on key. These are important audit guidelines that we received. We need to be able to fall in line with this. And this also gives the confidence to the services that the industry has quality service when it comes to security and other aspects. Now, another, of course, the services also can insist on certain guidelines and notes for ensuring cyber hygiene, or what if you are breached. It's important that the services know immediately, because they may be using this in an operation. You will never know as a vendor, but services will be at risk. So it is important that the industry also notifies services that they are under an attack, or they think this part of the code is compromised, or this part of the code is compromised, and this is their action plan to fix it. And like we discussed, the setting up standards for artificial intelligence is again a very, very critical thing, because future is going to be driven by most of the ML-based models, and setting up some standards is very critical there. Yeah, and one direction probably I think the services may look at, I can only recommend, is the special directive issued by the US White House. It's a simple 5-pointer, but very comprehensive. It gives a very interesting view to look at. And of course, for the friends from the industry, I think it is important that you also be ready for the black box testing type of environments. And if you're negotiating with a foreign vendor, please ensure that the foreign vendor understands the seriousness that the final end user would want to get the equipment tested for backdoors. And you can also, when you're building your own equipment, it is better that you also anticipate this and create it a part of your design. So that after you spend huge amount of money, the services should not simply say, go test it and come. It's really difficult to test an equipment after you've made it. And of course, please take care that you monitor your own networks. We have many tools and solutions available. I can also recommend creating of a exchange center for cybersecurity data. Like all of us, let's say the industry, we will be attacked by the same attacker. If the attacker is attacking Space Force, he will not only be attacking Space Force, he will always also be attacking all of us, because he doesn't know who is weak. All he needs is one entry. So by sharing data on who is attacking us in an automated fashion, which is what ISACs do, their information sharing centers on attacks, it is anonymous sharing of data. So at a sectoral level, we'll have some idea, okay, we are all attacked by this guy. And as a humble partner of the industry, I will.
We need to expedite.
Sir, thank you, sir. Yeah. Done, sir. It's the last slide. Thanks, sir.
And thank you so much for handling it from a very different angle, actually, attack surface angle, bringing in various views and challenges which actually we face, and bringing the AI angle in this. And then also bringing out the actions which can be taken at the design stage, before launch, deployment, and after deployment. It was a very interesting viewpoint. May I request Dr. Ranjana now, and ma'am, we are falling further short of time, so we'll cut the talk time to about 8 minutes now.
So I think a lot of important points are already being covered. So I will not go much into the detail, because I think industry has to provide a lot of service, and already I'm really impressed by that cybersecurity, whatever he has talked about. But you know, the IoMT has a lot of potential, and basically it is to unify the networks. And what goes through my mind apart from cybersecurity is the processors. And he touched a little bit on the processor, that if there is a backdoor on the processors, there is a need to actually have some kind of a evaluation mechanisms for all these kind of systems. And only thing is, how do we go about it is something that we have to talk among each other. Now, IoT programs and initiatives to be successful, the devices and sensors are to be connected, and the important data and data standards is another thing that we need to work out. So AI standards, cybersecurity standards, and the data connection standards, it will go a long way in standardizing the communication between the various elements that are, they will be communicating. Of course, the IoMT and IoBT, they are all basically depending on the connectedness. And unless until you later on writing wraparounds around these connectors will become a very, very tough challenge to, solve. And many of those computer systems have succeeded because they have followed certain kind of de facto standards or an organized kind of standards, consciously developed or something which has become de facto over a period of time of usage. Few more things is, the critical communications which is on the move and which are to the command center. So there is, some 3-4 sectors of communications that is need to be looked at. Sensor to sensor, then sensor to the your ground station, then sensor through satellite to the ground station, and from satellite to the upper layers of satellites. So there are certain segments which need to be worked out for this communication and made it robust and defined in the long run. Then the sensor's longevity and the kind of power requirement and its utility becomes another area where the IoBT and IoMT will be very important. Today most of this IoMT and all are based out of, I think, 5G or Wi-Fi kind of connectivity. Satellite connectivity is a totally different ball game, and a new architecture needs to be involved if the IoBT, IoMT has to be on the bandwagon of the SATCOM. Of course, it will give you a lot of advantages in the sector, because then you are not dependent on the availability of 5G and Wi-Fi, and anywhere it will be able to give you the connected thing. More than that, I think the weapons and already deployed systems in the defense will also have to be thought of IoMT and IoBT, which finally will be your today operational systems. If they are on the Internet of Things, then you have much better control rather than when we talk only about the soldier. So these are some of the points which come into this thing. AI and analytics, a lot has been talked about, and there are organizations which are working on the AI standards to be followed because AI can go rogue. It can mislead you, it can give you wrong answers. And not every part of AI, okay, I will not talk about large language models. They have matured to a certain extent, but again, they are based on the kind of data that you're feeding. And here we are not talking about the learned models, we are talking about the models which will learn on the go also. And that has a totally different segment of security or the kind of assurance that is required. And it has more potential to go rogue. So these are some things to be thought about when we plan to use AI. AI is yet to be used in the safety critical application. Most of it is right now in the assistive roles. Most of the AI, because we are still on the, so in fact it was some time back we started a project with IIIT Bangalore on the, is it possible to formally verify AI? And okay, certain few things, and it's a very interdisciplinary thing because formal and computer science is totally a mathematical science and AI was more of a practice. So we tried that let us have the two professors together brainstorm that whether we can do a formal verification of AI kind of models. Another thing is health monitoring systems for the sensors which are on board. This becomes a very essential part because which sensor malfunctions or whether it is really giving a value which is to be, caused an alert, which can cause an alert. So these are the health monitoring systems have to go miniature, integrated to the IoBT, IoMBT kind of things. Data storage and so we all know the data storage either at the device level or at the satellite level or at the command center level, optimized to be worked out between the three kind of segments. And I think the way forward could be the space qualified software defined radios. Now software defined radios need to be space qualified to be restartable, because once it is launched it is not even accessible to you other than through the software links or the communication links. So these are some of the design parameters which need some thought processes well in advance. Thank you very much.
Thank you, Dr. Ranjana. And touching on actually very, very important issues of the backdoors in the processors and requirement of standards for connectivity to the IoTs. I think those are normally commonly missed out things. And you also talked about the critical communication requirement within the various segments, making them robust, requirement of sensors, longevity in terms of power requirement, and also AI models going rogue. And lastly, the space qualified SDRs. I think this is a very important issues touched, and some new perspective in the whole IoT process has been brought in. Thank you so much. May I request Mr. Sanjeev Gupta to take a session.
Good morning to all. I'll just touch upon how satellite communication can be important to integrate with IoMT and IoBT. Everybody knows today the battlefield, lot of data need to be collected, and all the sensor has to communicate in real time to understand the situation of the bar, and the troop has to be communicated how they can go ahead, and lot of IoT can connect lot of the humans, ships, plan in real time, so all the real time decisions can be taken. The important why satellite is very important in IoBT and IoMT. The India, we have a different kind of geography. One side we have the sea area, one side we have the Himalayas, deserts. So satellite is a very important, can play a very important role where terrestrial networks are not there. All this IoT device directly can communicate to the satellites, and all the satellite network is very robust. You can deploy within no time whenever the need of communication is there. So it will have the very good impact in IoBT communication. So with this, with the integration with the IoMT and IoBT with the space sector, your recovery and response will be very fast. It will have the opportunity to improve situational awareness, like mobility of troops, track of cargo movement, information about terrains, weather conditions, improve military telemetry technology. Real time you can monitor the health of the soldiers. So today we are having total 18 communication satellite which is operating in different orbital slot from 48 degree east to 97.3 degrees. With this satellite we are having satellites in UHF, S-band, C-band, extended C-band, KU band, Ka band, and future is Q and V band. And wherever today these satellites we are giving 315 transponder which are being used by the various sectors like defense, government users, commercial usage. Similarly, wherever commercial requirement is there, we have leased the foreign capacity also through NCIL. Total, we have leased 111 transponder and around 2 GB data from the foreign satellite also. See, these are the typical coverage of our Indian satellites. We have the hugging coverage, which is generally used for the DTH purpose communication, and we in C-band we are having coverage from Europe to the South Asian countries, and we have the one satellite and GSAT-29 which is providing the special coverage over Jammu and Kashmir and northeast area, and we are having one sterile beam in this, so you can transmit wherever you need important communication, immediately you can steer this beam to provide the communication. And we have the S-band satellite, we are having the coverage over the sea also. Now next generation is the high throughput satellite, because today communication is the basic need. We need to send more and more data. So high throughput satellite is the next. Today India has launched 3 high throughput satellites, GSAT-19, GSAT-11 and GSAT-29. Total capacity we are providing around 25 Gbps. And next we are going to launch GSAT-20, which will increase our capacity to 48 Gbps. These satellites will be used for higher bandwidth data and voice communication. We can customize future satellites to cover the strategic locations, or we can use all this. These high throughput satellites is very important because they need very smaller antenna, so anywhere you can deploy the network. Now next future, already people have deployed in the IoT application, you need very low latency application satellite. With the latency is the very important to communicate IoT device to communicate with the satellite. So this LEO MEO constellation will help in this, and we are having 100% global coverage with these, and these are very important for low propagation loss and low, and cost is also very. Now so many startups or so many companies, OneWeb, SpaceX, they are deploying their network. So now security is the very important aspect. In the communication satellite, there are 4 components which where cyber can be attacked. One is space segment, one is the hub, your user link segment is a ground segment. Wherever, so industry need to develop the protocols or software where we can means security, we can nobody can breach our securities. So with the disruption of internet service, means any cyber attack is there, you will lose complete connectivity. So security is the very much important. Already people have covered all those things. So what is the step to be taken? We have to implement for the firewall on both the ground segment and user equipment to limit the access of unauthorized users. We have to improve authentication process for accessing internet use, for monitoring system, and we have to develop a lot of coordination between multiple SATCOM service providers, which they can use the common gateways or common security systems. So now these are the in satellite, in communication, how we can improve the security. We have to use software defined payloads where as per your requirement you can choose your bandwidth, power and your coverage area. We have to improve lot of digital onboard processing we have to do. We have to use smart antennas, we have to use high frequency bands. Now use up with the quantum technology, we can improve the security. So now this is the requirement from the industry. Your system should be vulnerable to the cyber attack. We have to be design a payload which should be flexible in terms of power, bandwidth and coverage. We have to have lot of collaboration between upstream and downstream SATCOM providers. And more to now the communication is the more important. We have to bring more number of spectrum and more number of orbital slots to provide the communication services. Thank you, sir.
First of all, thank you, Sanjeev, for sticking to time. That is, and also giving a very good insight into the existing national capacities for our satellite communication systems. Also, the steps taken by to be taken for security satellite systems, duly elaborated by you, draw a lot of lessons. Now I request Mr. Dilip, who is the last speaker on the panel.
Thank you, sir. Good morning, everyone. There will be a deck from my side. So I think while the deck is coming, maybe we'll just start and give in. So I come from QuNu Labs. We were actually set up in 2016 after China actually set up a quantum secure network. So we actually have been working and hearing about quantum computers coming in and the threat for that, right? So traditionally, so far, if you look at it, cybersecurity is looked at, okay, somebody is going to hack your system, somebody is going to put a malware, there will be a phishing attack and all of that, right? There is a, why so? Because everybody assumes that whatever communication is happening over the network or whatever data you are storing, right, is all safe. So with that assumption, typically cybersecurity is looked at attacks and all of that. But we have a tornado coming. Quantum computers are there, almost there. I think we already have 50 qubits launched, and we know probably that 500 qubits also is there. So it's a tornado which basically is going to reveal whatever is going over the network. So let's say you're using classical encryption mechanisms, you are let's say having data storage which is encrypted. All of that is actually at risk. None of them is safe. So basically, we are actually staring at Y2Q, which is year to quantum. That industry is saying, people are saying it will be around 2024 or so. So what is happening is that today anyone can actually just harvest the data that is flowing over the network on any medium, right? It's medium agnostic. So what we do actually is provide quantum secure communications, whether it is on any link. So we have two types of solutions. One, we actually have our indigenous quantum key distribution systems. We have, I think, probably the world's best portfolio of quantum key distribution systems, wherein actually we can provide a complete quantum secure communication network at the terrestrial level. We are in the process of building a similar system for a LEO satellite. We already have a capability of having a, let's say, a free space quantum key distribution network of around 2 kilometers. The next in line probably is going to be a drone-based secure communication, which should be coming end of this year. And in the last quarter of next year, we should be actually demonstrating a secure communication, a quantum safe communication from a LEO satellite to the ground station end of next year. So this is one part of the solution which we are already working on. There is other platform which we have, which is a post-quantum cryptography platform, which we called as QShield, that is already available. And using this platform, today itself, we can actually secure any communication going from any of the IoT devices, whether it's IoBT, IoMT, over the satellite to the hub station. So in case we can actually overlay it using the quantum tech and ensure that any communication that goes out is secure. We also have the technology today to secure the communication from the satellite to the ground station. So let's say if we have a surveillance satellite or a satellite which actually is giving, let's say, sensing data and passing it on to the hub stations, we have the capability to actually secure that. In fact, not just the data in motion, but we also have the capability to actually secure the data at rest. So for example, if you have a good amount of data, which surveillance data or any critical data that you have obtained, and you want to secure it, we can actually secure it. So the result would be that even if it gets hacked, the hacker would not be able to get the data, because it is secure and is going to be secure even with quantum computers. So that's what we do as we speak. We actually are in a very serious research and development phase for the quantum satellite key distribution for the satellites. We probably hope to build the technology to basically generate a pointing and tracking system with the accuracy of around 1 to 2 microradian. Currently, India has the technology to do it of around 1 milliradian, so it's 1,000-time improvement. We hope, and we continue to look for industry partners and research academia wherein we can actually collaborate, especially on this pointing and tracking system. It's a very, very involved technology. We are currently working with some professors in UK and Australia, and we continue to explore more opportunities around that. So I think overall, just to summarize, we have a tornado coming. We have quantum computers coming, which is going to break all communication, whether it is in motion or all data, whether it is in motion or on rest. We currently have the capability to make it quantum resistant, whether it is data in motion or data in rest. And we are working to make sure that all the satellite to ground communication becomes quantum secure, unconditional quantum secure, hopefully for the next 20-30 years. And looking for more collaboration from industry and also from the academia to succeed. Thank you so much, sir.
Thank you, Dilip. Dilip has spoken about a field actually which is going to be disruptive. He talked about quantum key distribution, free space quantum key distribution, and also talked about they are working on to give the quantum key distribution for the satellite systems. He also talked about the post-quantum cryptography actually is a very essential requirement to carry out the security for the data at rest as well as the data in transit. In fact, before moving on to for the questions of the session, I was just looking at some article today morning where the Chinese, the Tiangong 2 space lab had in last year transmitted quantum encryption keys to 4 ground stations. They already had a satellite, which is a Mischief satellite in space, which also transmitted these keys to the ground station. And now they have another satellite called Jinan 1, which is actually China's second quantum encryption satellite. And what the newspaper article was saying, it is saying that the Chinese state has actually started using quantum secure networks from the space. Now this is actually very serious. With this, I throw the session open to the audience for the question and answer session.
Just to add some of the concerns I said, you have a robust procurement manual and the guidelines on the security. On the 2 places, DAP Chapter 8 has got an exhaustive section and also certification by the industry, which is captured in page number 545 to 547. Malicious code and whole lot of things are you have to give the certificate. Thereafter, DPIIT 2014 manual on the security manual for the defense licensed industry. You have these are the 2. And also chapter 8 on the ICT and those system products. It's a unique that it talks of the QCBS system, unlike other procurement chapters, wherein the quality and the cost. And in that, the services would be advised to start putting the security concern at a higher places so that you get the best of the thing. Thank you.
Thank you for the input, sir. Yeah, please. You can kindly give your name also and.
Jan sir, I'm Karan Samasroiza. Sir, just a small query, is it being planned or not? In all IoMT or IoBT, it's basically geographically limited areas that will address. It can be interconnected though, meshed. So in this geographically interconnected areas, the demonstrated capabilities which are currently held world around of GPS spoofing or GPS jamming, PNT. And this technology is primarily dependent on PMT. That is the basic factor for IoMT or IoBT. So are we looking at something as a relevant counter to this? Because we are talking about processing, we are talking about communication. But the critical for this network part remains PNT. And it's very, very vulnerable in areas which are limited. The technologies exist with everyone. So should we be looking into something about this also? Thank you.
Would you like to take on, Dr. Ranjana?
Sir, with my little understanding, I think eventually we have seen the activity of people coordinating in close ranges using Bluetooth and extended Wi-Fi from the device itself. So eventually they will resolve themselves into a swarms, which is again where the AI becomes relatively important because the communication channel may not be reliable always. We may not be able to communicate with the group of IoBT or IoMT devices which are there in the battlefield. Again, we resolve back to the AI to take care of it. It has received an instruction. It's like, imagine probably similar to a submarine type scenario. You got an instruction, now you're not sure. What do you do next? So with that initial constraints, the IoBT devices, which probably would be on a near Wi-Fi network or near Bluetooth type network, something sort of a mesh like you said, can coordinate their activities by appointing one as a mothership. So let the mother decide and communicate. Now what if the babies go outside the range? I mean, these are the scenarios we have to plan and prepare for when you design the movements and plans, work plans. So it's like sort of preparing an SOP for AI.
I have one question directly for Mr. Krishna again. Okay. The question is, once we are talking of IoMT or IoBT devices, these are generally resource constrained, power constrained with a limited amount of processing power inbuilt. Putting AI, we are talking about AI on the edge. But is it not that once you are looking for a very, very specific applications, good old instrumentation, monitoring and control systems probably give us a more assured result, something whether going to AI which is a probabilistic in nature and probably when at a design stage will not be able to achieve a say 99% kind of accuracy.
It's a very, very fair point. I think you highlighted the core problem that we have today in AI. So most of the AI research today is driven by what we generally call as correlations. Now, I'm sure some of you would have heard that when Sachin Tendulkar scores say 90, we win. There's no logic there. There's no connectivity there. But it's a statistical fact. Now, current AI engines mostly thrive on that. But I do see a lot of active research that is happening on what is believed as causal relationships. So now that is the type of AI models I think we will depend on for critical jobs, say warfare or even medicine or healthcare. So I think that is where those sort of AI's misbehaving situations would be reduced. Now, there are also many ensemble models, like, for example, you don't use one model, you use multiple models to weigh them out and then put thresholds. So that work is also happening, but like you said, if you use ensemble models, you create a you need much larger resources,
Much
which,
larger
like you said, yeah.
Ensemble models not possible on the...
But sir, we are also betting on the increased availability of computing power in the edge. I'm sure the iPhone that we see today is far better than the supercomputer we probably used when we were in college. So, yeah, that's another thing that we are betting on. I hope I've clarified.
Second question for Mr. Dilip. The Mission series of satellites which 2016 China launched and it came into that they are having a quantum kind of a key distribution. Once it are further analyzed, you actually realize it could only transmit 50 kilobytes of data over a 24-hour cycle, that also point to point. Presently, all SATCOM-based QKDs which you are visualizing, as of now, the theory is only limited to point to point. However, is there a plan to escalate it to point to multi-point? Because any kind of a user which is looking at, he's looking to distribute his key to a network. His role is not interested for point to point. And what kind of data rates you are visualizing in your satellite which you're planning, to launch or test on this in December next year?
Thank you. So, very good question. So, see, basically the QKD systems are not the data transmission systems. Right. So the QKD systems ensure that the two endpoints get a symmetric key, which nobody can hack, which is then used for encryption and decryption. So the way we plan is a combination of terrestrial and satellite-based QKD network. So it is not going to be one satellite. So for example, if I talk about India, let's say, right, I can typically plan around 15 to 20 stations which will cover India, which would be, let's say, connected over a satellite. And then locally, they would be connected, let's say, using a terrestrial network. So now the entire network, right, for the entire network to communicate, we basically need a symmetry key to be generated from one point to any other point. That's it. So even if let's say, I talk about, for example, 5 minutes of visibility for a satellite, right, I would be able to generate around 1 megabits of symmetry keys between two endpoints. So that 1 megabit of symmetry key is good enough for me to actually communicate with more than 1,000 endpoints for 24 hours. So the data can flow on any medium. The data can flow either on the terrestrial network or over the satellite, but I would have enough keys generated to actually take care of communication anywhere for 24 hours. So that's the logic which we are looking at.
Yeah, I have a question. It is not directly related to communications as such, but India has onboarded that Digital India RISC-V program for microprocessors and microcontrollers. We're talking about IoTs today. I just want to know how is this going to, this for industry and commercial standards. Are we also looking at it for the military purposes?
I can start the answer and then somebody else can take on. We in the Army, sir, we are also looking at it. We are actually collaborating with one of the leading IITs, which is worked on the standard, and they collaborated on the standards. We are working on an HD device which has had this RISC-V processors, and we're looking to take it forward. Sir. That's the input, sir.
Good morning, sir. Sir, actually, I'm from DRDO. We fly these meal UAVs. In one of the incidents for the operational missions, actually, we had a very peculiar thing. We had a valid but undesirable command for the UAV, which becomes very critical at situations. Is it possible that an adversary is sitting somewhere in the mainland or in the nearby ocean or just monitoring our transmissions and sending us command which is similar to our protocols, first? And second is there any way of localizing those transmissions, geolocalizing them, and making out, how costly it's going to be in near real time? And second is, if we are going offline, is there an agency like NOCC or ISRO monitoring those transmissions and penalizing whether it's a licensed user or whether it is actually a rogue element trying to interfere with our signal? Is there a way of how costly it's going to be to identify that location, transmission to near real time and offline at the same time?
So we do have geolocation systems, and I think NOCC, DOT, they are also bringing up the centralized monitoring, carrier monitoring facilities. With that, you can monitor any RF signal from where it is being originated. And if it is unauthorized, yes, maybe some penalty clause may be there. I don't know. This has DOT may be bringing, NOCC is the nodal agency to monitor all the RF carriers.
I think this, we'll take it as the last question for the House. And all that remains for me to thank the esteemed panelists for bringing out various aspects of IoMTs and the communication, satellite communication security, and the various nuances, how the cyber attacks and attack surfaces can come and how we can protect and work against that, ranging from the classical processes to going up to the QKDs and the quantum domain. And I also would like to thank the audience for throwing in very, very incisive questions and extracting some good answers from the panelists. Thank you so much.
Thank you, esteemed Chair. May I request you to kindly do us the honors of presenting memento to the esteemed speakers as a token of our appreciation and thanks. We thank Mr. Sanjiv K. Gupta. Our thanks to Mr. Vinod Kaul. Thanks to Mr. Sai Krishna. We thank Mr. Dilip Singh. And thank you, Dr. Ranjana, for being a part of this session. And to present a memento to the esteemed chair of the session, may I request Dr. Subbarao, President SIA-INDIA, to please join us. Thank you to Major General Sanjeev Sharma, the esteemed chair. Thank you, Dr. Subbarao, for doing us the honors. Moving on quickly.